Okay, so we have a piecewise function here, three pieces. The top piece is what shape? It's a V shape, and what kind of equation is it? What's it called? Absolute value, and actually they say linear absolute value is the full name, but I'm okay with absolute value. And then the second one is what kind? Exponential, and the third one? Quadratic, which makes what shape? Parabola. Okay, so we got three shapes to work with here. I'm going to work with the one at a time. And so y equals 1/2 absolute value of x plus 2 is going to work with first. So first, this is a V shape, as we said. That plus 2 tells us to go to the left 2 from 0, 0. And in fact, we know that that's the vertex of the of our V shape. Okay, and then this 1/2 also has significance for us. That is the slope of the right side. Okay. All right. And then I'm also paying attention to this part right here. I need to know what the value is when x is 0. And I may get that if I start graphing this, but I just need to realize, okay, I only want to graph this when x is less than or equal to 0. So I don't want it on the right side of the y-axis, only on the left side of the y-axis. I'm gonna graph what I have so far. So the vertex we said was left 2. And I'm forgetting what the slope. Slope was up 1, right 2. And that got me to the y-axis. And I know I don't want to pass over that. But I do need to pay attention at that endpoint. Should it be an open circle or a closed circle? And I'm noticing it's a greater than or equal, which is going to make that a closed circle. So at 0, what is the point? 0, 1, it's going to be closed. Okay. So make sure it's obvious that it's closed there, and that's my first piece. I'm going to switch color now for my second piece. Second piece, y equals 2 to the power of x minus 6. And I know that this is exponential, and it's moved down 6 from where? From 0, 1 this time. Okay? And 0, 1 is not a vertex or any special point. It's just a point. Actually, it is the point that was 1 unit above the horizontal asymptote. Okay? So when I move down 6 from 0, 1, I also need to move that vertical asymptote down and make sure that's 1 unit below. So I'll do that. And is it going to be open? That's an endpoint, huh? Is that going to be an open circle or closed circle? Open because of this sign right here. So from 0, 1, I'm going to drop down 1, 2, 3, 4, 5, 6. Open circle there. There is this invisible, I'm going to make it visible, horizontal asymptote 1 unit below that. That would give this thing shape. Okay. And I need another point, but I'm going to use 2 because that's my second endpoint. So I'm going to plug in 2 to see what I get. So if x is 2, then y is going to be 2 to the second minus 6, which is negative 2. So 2, negative 2, open or closed? Open, because again, that symbol is just a less than sign, no equal sign. So at 2, negative 2, I'm going to put an open circle. And it's an exponential growth, so it's this kind of a curve similar to what you see with a parabola. Okay. And that's the second piece. Done with that one. On to the third piece. Switch colors again. I'll go black ink. And so we have y equals x minus 3 squared. Okay, and that's 2 less than x less than or equal to 5. Okay, so vertex is going to be right 3 from 0, 0. That's the first point I'm going to put on. So 1, 2, 3 right there. And then my endpoints. I need to know what's happening at 2. So I plug in 2. When x is 2, y is going to be 2 minus 3 squared, or negative 1 squared, which is 1. So 2, 1, open or closed? This one's open because there's no equal sign. So at 2, 1, open circle. We got a matching point on this because it's symmetric. It creates that U shape. But then it ends at 5. So plug in x equals 5. We get 2 squared, which is 4. So 5, 4, open or closed? This one's going to be closed because we do have an equal sign. X is less than or equal to 5. So 5, 4, 1, 2, 3, 4, 5, up 1, 2, 3, 4 right there. That's your graph. That's what you want. Okay? It looks like 3 separate pieces. It is, but it's one function. All 3 of those together form that one function. For our domain, what is it? Anybody have it? Negative infinity up to 2, parenthesis or bracket, union 2, 5, bracket. Okay, so here's, if you're having troubles coming up with this, domain is only x values. And so you know it's going to go from negative infinity to 5. Okay, the furthest left, there's an arrow, it's going to go to negative infinity. Furthest right is 5. In between, you're checking, is there a x value in between that's not represented? And you only check at the break. So there's a break at 0, but we have a closed circle at 0, which means we still have it's still represented there. And then there's a break at 2, but both those endpoints have open circles, so that means there is no x value represented there, and so we have to have that break in the domain. For the range, we definitely see a break in the range, right? Anybody want to try that one? Chase? Careful. It does go to infinity, but there you see are there some y values that aren't represented? Can anybody give me one y value for sure that's not part of this graph? Negative 1's not part of the graph. You see that, Chase? So from negative, you said negative 5 up to here. And then there's this gap. So try it again, Chase. Yeah. Union. Negative 2. Oh, parenthesis. All right. I'll come back to Chase. So the first one's good. Second one, though, birthday boy. Bracket 0. And we'll talk about this up to infinity. So here's why. I'm going to just highlight the y-axis. So these y values are covered. And then there's a gap. And then it starts here, and these y values are covered. Okay, that's when we're talking about range. We're only looking at y values that are represented in our graph. And so we went from negative 5 to 2 here. But we couldn't start back up at 2 because there's nothing here. So we have to start back here at 0, which both of these are represented. And did I use bracket? Yeah, bracket 0, because we want to include that. And then up to infinity. Now that up to infinity doesn't, it's not from here, right? It's coming from this. This is going up to infinity. Okay. So when you're evaluating, if you have a graph and a function, you could pick which one you want to evaluate from. And often it's quicker and easier to evaluate just from the graph. So for example, f of -4, well, I could say, well, where's -4? 1, 2, 3, 4. That point right there. So what's the y value of that point? 1. And so we know f of -4 is 1. You could also plug it into the equation above, and that would give you 1 as well. F of 2, again, using the graph, what happens at 2? It's not part of our domain. So it's undefined. F of 3, we go to the right 3. What's the y value? 0. And f of 6, that's outside of our range, or outside of our domain, sorry. Undefined. Okay. All right, so this stuff puts everything together. The whole unit is just in this. Everything in the unit's been building up to this, being able to graph these, and then also write the equations of these. Yeah. Okay, so you were using the function, and we said f of what? F of -4. So is -4 less than or equal to 0? So we want to use this one. You were using which one? And so you're thinking +4. Okay. All right. We have time. We'll come back to this other one. I want to now go the other direction. So where we have a graph, we got to write the equation. Okay. So when you're writing an equation, you first want to decide how many pieces are there. And you have some options on this one, maybe. How many pieces do you see? You see 2 pieces? Now just be careful. Because it looks like a V doesn't mean it always is. And so here's all you have to check. So we're thinking this is an absolute value here, right? If the slope of the right-hand side is equal to the negative slope over here, then you're good to go. But if this was like a slope of 1 and this was a slope of -2, then it wouldn't fall under that absolute value. So you have to have perfect symmetry. I'm just saying this one we do have it, but there are some cases that will come up where it looks like a V shape, but it's really not an absolute value. And so if you run into that case, then you're just going to have to split it into 2 lines. Okay. So we have one piece here, second piece right here. And so when we write our answer, we're going to say f of x is equal to, we use the curly brackets, and we'll have our first equation. I'll put equation 1 here. So that would be the equation of the yellow graph. And then equation 2 would go here. That would be the equation of the blue graph. Usually go from left to right, goes from top down. And then if you look at the examples up above, have your equation, and then it says the word for. Sometimes we use the word if. And then you want your restriction or your domain restriction. So we'll use the word for. And then I'll put domain 1 and domain 2. And here, when you're writing your domain, you're using inequality notation, now not interval notation. And so I'm going to give you a little time again to think. So come up with the equations of those, and then what are the domains for those? Okay. So I'm going to, again, demonstrate, just go over this real quick. Two different equations got to come up with, and then two different domains to look at. So the first equation on the left-hand side has a vertex at negative 1, 2, 3, 4, negative 1. And so the parent graph is typically at 0, 0, and so it's been moved to the left 4 down 1 from 0, 0. And so if I'm working, the parent graph of this would be y equals something times the absolute value of x, but it's been moved left 4 down 1. And so I'm going to rewrite that as y equals a times absolute value of x plus 4 minus 1. Okay. And then I need to find out what a is. A is the slope of the right-hand side. And so I pick 2 points on the right-hand side and just count, well, what's the rise over run? So I go up 2, right 2. And so a is going to be 2 over 2, which is 1. And so now I have my first equation. So f of x is y equals absolute value of x plus 4 minus 1. Okay. There is a domain part there, and I'm going to put that in right now. So 4. So how far left is that yellow one going? Negative infinity, less than x, all the way up to how far right does the yellow one go? Negative 2. Now I get to pick open circle, closed circle. I'll make it equal to it, so I'll put less than or equal. Okay. Now for the second equation. It's a parabola. The parent graph is y equals something x squared, but it's been translated. And I'm focusing on the vertex because the vertex is the parent graph point that's been moved. Okay. Okay, so the vertex is at negative 1, 2. And so I've gone left 1 and up 2. And so I need to rewrite this as y equals a x plus 1 squared plus 2. And now I got to figure out what a is. There's no slope on this, so I can't use the slope to help me find a. I have to pick another point that I know for sure it goes through. I can't use the vertex because I've already used that for my translation. And so I'm going to pick this point that they share, or I could pick the point on the other side. It doesn't matter. I'll use 0, 1. So I'm going to plug in 1 for y and 0 for x. And I end up with 1 is equal to a times 1 squared plus 2. Can I add the 1 and the 2 here? No. But I can subtract 2 from both sides of the equation. So get negative 1 equals a times 1. And so a is negative 1. And so my equation is y equals negative x plus 1 squared plus 2. And the domain starts at negative 2. This time I'm not going to include it because I included 2 on the equation above. And it goes to what? How far right? To infinity. Okay. So now some variations here. So notice I have an equal sign here, and then I put y equals here. I really don't need that part, so I'm going to erase the y equals. Okay. And if you go back and look at the examples of these, they don't have the y equals there. Also, I don't need to put infinities. You could, but you don't need them. You could just have x less than or equal to negative 2 and negative 2 less than x. That's fine as well. Okay. But this right here is the equation you want to come up with. Okay. Question on that? Yeah. Okay. Okay. All right.